Hello, Year 10. Welcome back to another week. We're continuing with our unit on linear relationships and sketching graphs. Today, we're going to be learning how we can sketch a line given its equation. So we're not even going to bother with a table of values today. Today, we're going to learn a quick way that we can look at an equation and know the key features straight away what we need to be able to sketch that line. Okay, we're going to start with horizontal and vertical lines, and then we're going to move on to what are called oblique lines or diagonal lines, which are a little harder, but if we know the trick, aren't too bad. Okay, so we're going to sketch the following lines here. If we look at the first one, we're going to sketch this line x equals 3. So the first thing we note about this equation is there's no y, it's just x and then equals 3. So what that is telling us is that y changing doesn't matter at all for this line that we're about to draw. So y can be whatever it wants, and no matter what y is, x is always going to equal 3. So what we need to do is point all, or to have a line in which all the points on that line obey this rule that x equals 3. And what we're going to end up with is actually just a simple straight line here. So here we can write 3. This is our x-axis, this is our y-axis. This is a straight line you would draw with a ruler. Okay? And how does this line represent that equation here? Well, if we take a point here, for example, which is going to be x equals, or it's going to be 3 minus 3, okay? We've just got to ask ourselves, does that point satisfy the equation x equals 3? Is x equal 3? Yes, the x value of this point is 3, so it lies on that line. It doesn't matter what the y value is in this example. We could take this point here, which is going to be 3, 6, and of course the same thing applies. X equals 3, great, it's on the line, and y, it doesn't matter what y is, okay? Any other point that's not on the line is going to have a different x value to 3. So that's what a line is. It's just all of the points that satisfy the equation. In this case, it's just that vertical line there at the point x equals 3. All right, now, this next one here, it's y equals minus 2. And we notice again, there's only a y in this equation. There's no x. So all we have to think about is, what are all the points that satisfy the equation y equals minus 2? Well, what it's going to end up being is just a horizontal line this time at y equals 2. Okay, and so this is at 2 here. And again, we can just consider any point. Let's look at this point here. It's going to be x equals minus 5. Oh, sorry, I've made a big boo-boo here. Make sure you look at this carefully, okay? We're looking at the line y equals minus 2, not y equals 2, okay? So hopefully you learn from my mistake here. We need to make sure we're at the minus direction, which is down on the y-axis. So this is at minus 2, and it's going to be a horizontal line across here. So excuse me for making my mistake, but hopefully that will help you to realize, got to watch out for that and make sure you get it in the right spot. So again, let's consider this point here. X equals minus 5, and then y is minus 2. Does it satisfy the equation? Yes, it does, because the y value is minus 2. So again, we can pick any point on that line, and it will have the y value of minus 2. So therefore, it's on the line. So basically, if you have an equation that's just x equals something, you're going to end up with a vertical line somewhere, depending on what x equals. If you end up with y equals something, you're going to end up with this horizontal line at that y value there. Now, that might be a little confusing because y is the vertical axis, but what that means is just all of the vertical components of these points are the same. So therefore, it's just all of the horizontal things that are going to change. And the same for the x's, it's the vertical component that can change, the horizontal component stays the same. That's why you get a vertical line with x equals something and a horizontal line for y equals something. All right, let's look at a few of these other ones here. Now, we notice straight away that these equations have a y and an x, so they're not so straightforward. So what we need to look for are two really important features. That is the gradient, okay, and the intercept, or specifically the y-intercept. Those are going to be our two things that we need to look for in our equation that are going to help us sketch our line. Now, the gradient, in gradient intercept form, if you just have y equals, then that equation is going to be in gradient intercept form, given that it's a line that we're looking at. Okay, so if it's just y equals something x plus or minus something, then that's gradient intercept form. Now, the gradient is whatever the coefficient of x is, that is the number in front of the x. It could be a negative number, it could be a fraction, it could be a whole number that's positive. Whatever it is, the number in front of the x is the gradient, which is going to tell us the slope of the line. And then the y-intercept is going to be whatever is not in front of the x. So the +2 or the -1 or whatever it is, that's going to tell us what the y-intercept is, okay? I'm going to teach you how to sketch a line given the fact that you can work out only these two features of the line. So the gradient of y equals x plus 2 is just going to be 1, because the number in front of x is, you can't see it, it's the invisible 1 that's always in front of pronumeral. And the y-intercept is going to be +2, because +2 is the number after x. So what we're going to do is we're going to straight away put that +2 points down. Okay, that's the first point that we're going to make here. The y-intercept is always where we want to start when we're sketching a line. Always start the y-intercept, and I'm just going to put there, so it's going to be 0, 2 as our first point. And then all we need to do is find another point on the line, and we can do that using the gradient. Because the gradient is 1, that means every time we go across 1, we go up 1. So I can find this point here, 1, 3, okay? Because every time I go across 1, I go up 1, and that's going to be another point that we can use. Now we can use these 2 points now, and we can just draw a line between them, but extend that line beyond those points so it continues. So we end up with this straight line like this, right through here. That is our line here, and that's the line y equals x plus 2. Now, how do we know that's the line? Because we've got the gradient right, and we've got the y-intercept right, okay? So once you know the gradient and the y-intercept, okay, I'm going to write that down. So grad equals 1, intercept equals 2. Just as a little note, see how you're working it out. Now, for b here, we have y equals -2x. So the number in front of x, the gradient, equals -2, and the intercept, okay, now there's no plus or minus any number after the x, so the intercept is just 0. Okay, if there's no number there, then 0 is the intercept. So straight away, the first point that we always put down is the y-intercept, and in this case, the y-intercept is going to be 0, 0. Okay, because it just goes through the origin there. When x is 0 in that equation, y is also 0. Okay, the next thing we need to do is find another point. Now the gradient here is -2, which means every time we go to the right one, we're going to go down 2. Okay, so if we go across 1 and we go down 2, that will give us another point on this line here. So 1 minus 2 is going to be another point on this line. Now we can create this line again by drawing these points together and then making sure we're using that ruler so that that line continues straight through. So it's going to cut through like this. Okay, continue on down there. It's going to go up like this as well. Make sure it's nice and straight. And then we want to label it with the equation. So it's y equals -2x is that equation there. You can see for each of these lines, I've drawn the line through the points. I've put arrows at the end saying that these lines go on in those directions. I plotted 2 points on that line, and I've also written the equation of that line next to it so that you know that that's the line that we're looking at. Okay, we've got one more equation here. We look at the equation, we can straight away see that the gradient is a half and the intercept is -1. The y-intercept is -1. So the first point we can put on this line can be 0, -1. That's the intercept. And then every time we go across one, we go up half. Now, it's good to pick a point that is a whole number. So if we go half when we go across one, we go across another one, we're going to be going up a whole 1, which means that we're going to go across 2 and up 1, and that's going to give us our next point here, which is going to be 2, 0. Okay, we've gone across 2 on the x-axis, and we're at 0 on the y-axis. Now, our line here again can go through these points, and every time it goes across 1, it goes up a half, which means that every time we go across 2, we go up 1, and then we can continue our line with that slope there. So you see, we've got our line y equals half x minus 1. You see the steepness of that line is half as much as the line above it, x plus 2, but it's also in the positive direction there. So there you can see we've graphed 3 lines on this axis here by using just the gradient and the intercept by looking at the equation. The number in front of the x is the gradient, the number after is the y-intercept. That is, where does it cross the y-axis? Okay, I hope you've understood this video. Do let me know if you have any questions, and I'll see you in the next video.